Hello. Okay. All right. Welcome to the second session of the practical introduction to analytics. In the previous session, we were talking about um, the definition of analytics, um, of course, the types of analytics, and how does it look like in the future. So now, for this session, we will cover the layers of analytics. So this is one level deeper into the actual thing, right? So what we are gonna cover today, as I've said, yeah, layers and stages of analytics, and the roles, because there are more than one roles in analytics, not just data analysts. There's also data scientists and the engineers as well. So we will cover that one later on, um, and of course the tech stack um, that are used in analytics. Okay, so let's begin with the layers of analytics. So I want you to imagine, if you want to analyze something, if you want to visualize something, um, that something is of course the data. Uh, of course, you will have to start with having a data first. Um, so let's draw that one here. Let me zoom in a little bit. So these are the major layers of analytics. We've got ingestion. Um, we have transformation. We have analysis. Um, predictions, um, and reporting. And then let's connect all of them together. So from ingestion, where's the arrow? To transformation, from transformation to analysis, from analysis to reporting. Um, and then this can go like this, and this can also go like this. Oops, how did I do that? Nope. All right. Okay. So let's start with ingestion. So this is the part of the analytics where you ingest, you take data from other sources into the workspace of or the environment for analytics, and this is where data warehousing or data warehouse um, comes into play, because once you ingest data, let's say from external sources, like if you run um, marketing campaigns, let's say on TikTok or in Facebook, and you want to collect your marketing data, how well your campaigns are performing. So you're gonna pull those data from TikTok and from Meta. You should have a place to store them, um, and that's the purpose of data warehouse, right? So you take those data, you ingest those data, and you load or you save it in a data warehouse, and that's um, that's also the place. The data warehouse is also the place where you would put the copy of your product databases. So if you run an app, or like a mobile app or a web app, uh, those apps use tables, they use databases, but you can perform analytics directly on the same database that's being used by your app. Okay, so you have to make a copy of that data into your data warehouse, right? Because you can't use the product database for analytics. we will talk about that one later on, why we can't just use them. Um, but for now, understand that there's a different, those databases serve different purpose. Okay, and data warehouse, its purpose is for analytics. So data warehouse is where everything uh, are stored. It's the first landing of your data. So that's ingestion, right? You take data from other sources into your data warehouse. So this is where concepts like ETL or ELT um comes into play. All right. So what happens after ingestion? Once you have the data in your data warehouse, transformation comes next. For obvious reasons, right? Uh, those data are needs to be cleaned. It's not in the right format for to perform analysis, right? So some of them are still in JSON format, some in maybe in the right tabular format or relational format, but um, there's a lot of cleaning to do first. So that's where transformation happens. So the output of this layer is um, well-defined tables or data models, so they say, um, that reflects the business logic behind those uh, behind those data, right? So, say for instance, the data that you ingested is a very wide table, let's say 100 columns, right? So one thing that the transformation can do for you is to break those very long table into smaller, leaner tables so that it's easier for you to analyze. Okay, so what happens after that? Now, once you have transformed data models or tables, you can now perform analysis on those tables. So um, you can use those transformed tables to make your to do your investigations, to do um, to explore the data, right? So this is where uh, analysis is enabled, because you can't analyze something if you have raw and unclean data before. So that's analysis. And is if you can know if you notice, there's another branch coming from transformation going into the predictions layer. So the predictions layer or the forecasting layer, this is uh, things like machine learning come into play. So before you can train machine learning models, you can't just like pass data into it. You can't just it's not, for most part, it's not plug and play. So you have to perform analysis first, and once you have a solid understanding of the data, then you can start working on your prediction models. But once you have a working model, and all those pre-processing steps for your prediction models are uh, coded, then this is where this other branch come in. So because you already analyzed the data beforehand, updating the prediction model can be as easy as from transformation going into the machine learning model, right? Um, but yeah, it doesn't strictly go from here transformation to predictions, or from transformation analysis and prediction. So there's no like uh, like a clean single flow. So most of them really depends on the situation. But oftentimes you really have to go from transformation analysis and predictions. Okay. And then the next layer after this layer is the reporting. So once you've analyzed the data, you found the insights, now it's time for you to create a report or create a dashboard out of it. That's the next layer. That's reporting layer. Okay. So these are the major layers of um, of analytics. Okay, so the next thing that we will cover are the roles. Okay, so who are the people that covers which layer, or what roles cover which layer, and what do they do? What tools do they use? That would be the third topic that we will talk about, the tech and the tools. All right, so let's start with ingestion. So this is um, handled by the data engineers. Okay, so as I've explained earlier, ingestion is taking data from different sources into the data warehouse. So it's the data engineer's responsibility to create pipelines that would do that. So I've also mentioned these terms, ETL and ELT, extract, transform, load. And most modern stacks, it's not ETL, it's ELT, so extract, load, and then transformation. So these are the things that if you want to be a data engineer, these are the things that you need to understand very deeply. Okay, so now let's talk about the why we need to replicate. Well, not exactly replicate, but why we need to have a copy of your product database into the data warehouse, why we can't just use the product database, right? Why bother copying the data over to a data warehouse if we can just use, right, the product database? So the reason is that those two databases have different purpose, and they are optimized to serve those types of purpose. So if we take let's say this one is your product database, um, and then this is your data warehouse. So your product database is transactional, or OLTP, and the data warehouse is analytical. All right. So this is okay. So let's start with the product database first. Uh, how does it work, or what are the things that it does for us? So if you imagine having a mobile app, like let's say you work for a company that has a mobile app. Um, if a user logs in to the app, um, now if a user signs up for the first time, right, into the app, the user information must be saved somewhere so that when they log in again, um, they can essentially authenticate, because we can see in the database that this user already signed up before. um, so if he or she wants to log in, we can use the authentication information of that user, because we already have it in our database. So that database that I'm talking about, that's the product database. So all this information that you can see in your app, like let's say payment information, your past orders, for instance, past transactions, you can scroll through all your past transactions right in the app. So all this information, you can see those information because behind that app is a product database. So when you log in and you go into the let's say the transaction history, right? Um, and you can see your entire history there. The reason why it's showing there, because your app is querying the product database to show those transaction history. Okay, so that's the purpose of this product database. It is for your app. It is for your product, whatever your product is. Okay. And it's optimized. It's an OLTP database. The T here means transactional, meaning it's optimized for those type of purpose. Meaning for that single user, the only data that that user can see are those data that they are allowed to see. So if they go to transactions page of their app, they should only see their own transaction and not the transactions of other people, right? Their own orders, their own account information, user details. It's all about them and not about other people. So that's the purpose of the product database. Now, if you think about the analytics, what if we just do what if we just perform analytics in the product database, right? We already have the data here. Why not? So remember, the purpose of analytics is more of aggregation of data as opposed to the product database, which is isolated to a single user at a time. So if you have like 1,000 users uh, logged in at the same time, all of them will just have access to their own data. Um, Now, analytics, on the other hand, makes reports. So those reports, those dashboards are uh, most of the time aggregated. So if you want to report on, let's say, the number of orders in the last month, um, what analytics would do is to take all those orders data from the product database and count the number of orders and then group them, let's say, by month, and then you have something to report. You have something to use for your dashboard, right? Um, and then notice the difference. For analytics, you need the total per month, total number of orders, regardless of whoever the user is. Remember, in Product DB, the app can only display um, their own data, right? But for analytics, no, there's no isolation per user. If you want to perform analytics, it's gonna use everything. So that's the difference in terms of purpose, because this database is optimized for smaller transactions, small frequent transactions. Okay, most of the time it's on a user level, right? But for data warehouse, it's by batch. So it takes in a huge amount of data and collapses it or aggregates it on a certain level and then makes a report out of it. Okay, so data warehouse is optimized for that type of operation. If you use or you perform analytics directly, if you use the tables in this product DB for reporting, let's say you take the total number of orders using this product database, it's going to read all of those data. And because it's going to read all of those orders data, chances are the experience of your customers will be affected, because the database that they're using on their phone are being used by some other processes. So there's going to be a race condition of who gets access to the database. So if you do that, maybe your app will break, it will lag or whatever. So it's a bad customer experience. So what you do in analytics, what you do is to make a copy of those data, um, so that you can use it for reporting. That's why you need a data warehouse for that. So once you make a copy, remember that that data or that table needs to be in sync with the product database. Otherwise, it will go stale after a couple of um, hold on. I realize I am not showing this part in the screen. Anyway, if you um, ingest the data into your data warehouse from your product database, remember that at some point that copy will become stale, because the product database keeps on updating, right? New users sign up, there's new transactions and new orders. And so your data warehouse copy of that table needs to um, needs to keep itself in sync with the product database. So there must be some type of scheduled um, ingestion, right? So that at a certain frequency, that your version of the table in the data warehouse is in sync with the product database. And because this is reporting, there's less pressure to use live data or updated data, right? So even if your standard, if the standard in your analytics team is 1 day 1 day freshness, so then that means that there's an understanding already that the latest data that you can find in the data warehouse is yesterday's data, because your data warehouse only refreshes once a day, and that's okay, right? In some companies, maybe it's more frequent, like your data warehouse refreshes every 4 hours or every 2 hours, right? But it's very difficult to do this in real time, um, syncing both in real time, because that's number one. First of all, it's not really that useful for analytics, real-time data. Real-time data is for the product database. Okay, so this is your area if you're a data engineer. All right, so yeah, these are things that even if you are, like me, a data analyst and a data scientist, these are things that you need to understand, because if you're investigating something like the data is stale or the data is not updated, you know exactly where to look at. So maybe the scheduled refresh of your data warehouse is not working. So it's easier for the analysts and the scientists to communicate with the data engineers what they feel wrong about the data or the pipeline. Yeah, that's why this is very important for even for analysts and scientists. Okay, so transformation layer. This is for the analytics engineers. So what happens here, as I've mentioned, they transform the data into something that's useful, that's reusable, and consistent. So this is where metrics are defined. This is where business logic are embedded into the data. So analytics engineers are um, not only technical, but they are also they should also have the capability to understand the business side of the data, um, because it's very difficult to transform the data into something useful if you don't know exactly how, what's the operations behind the data, like how it was generated, why it was generated in the first place, um, what are the rules that needs to be uh, embedded into the data. Like for instance, if you have like test customers for the development side, in product side, right? They have, like, they add test customers into the database to test some features, right? If you don't know those rules exist, like there are test customers, if you don't know those rules and you were not able to filter those out in your data, then the rest of the analytics pipeline are incorrect. So if you're counting the number of customers, you are also counting those test customers. So that's a simplified, a very simple example of why in this layer it's very important that the analytics engineers also understand um, the business logic. So if you want to be an analytics engineer, you must be willing to communicate with product teams, with marketing, so you know uh, across all domain that generate data, and once you have a report, you must be willing to learn their ways so that you can model their logic into the data correctly. So what comes after that is um, analysis. So obviously this is where analysts and scientists work. And similarly for predictions, it's also the scientist. Okay, so after transformation, depending on the use case, as I've said earlier, those data can feed directly into predictions model, um, or depending on how things are, if they want to create a new model, then they need to do some analysis first before they can do predictions. That's why in the analysis layer, both the analyst and the scientist uh, work in that layer. So analysis is so it yeah it really depends on what you're doing, right? So for a data analyst, if you're investigating something, so if let's say your executives are asking why our revenue was down in the last 6 months, 3 months, and you're investigating something, so this is where data scientists do their investigations or analysis, and they will uncover insights, they will uncover the answers, and most importantly, they can use those analyses to make recommendations, to make suggestions to the stakeholders. And then for the data scientist, yeah, it could go both ways, right? From transformation or for coming from analysis. Um, they can do their prediction models here. So predictions are this is the area for machine learning. So data scientists are required or expected to have understanding of high level mathematics, like calculus and linear algebra. Okay, so this is the area for math heavy people. But recently there's been a lot of automations that's been happening on this part of the layer. There's been AI who can do the pre-processing for the data scientists, who can perform iterations, who can monitor the training of the prediction models. So there's been a lot of tools already that exist to help data scientists in this layer. But yeah, that remains to be the area for data scientists. And then the last layer of analytics is reporting, which is dominated by data analysts. In some instances, the the experiments that the data scientists do, in some instances, they also make a report out of that. But for the sake of simplicity, let's just say that this is the area of the data analyst. So reporting or the dashboard. So this is what people tell you that data analysts, you know, creates reports, they create dashboards, and that's basically what they do. Um, but that's not all. That's just part of the job, right, for data analysts. So remember that the purpose of reporting and dashboarding is um, for primarily for decision support. Sometimes it's for monitoring purposes, right? And sometimes for overall for decision making, really. So that's like a huge part of a company. Um, so yeah, that should be all for the layers. What I want to cover next is the tech or the tools that each of the layers use. Okay, so going back here for the data engineers, so you need to have. I've already mentioned this one. You need to have the the skill set to be able to understand system design. Um, So in terms of tooling and tech stack, it can really vary a lot for different teams, right? ETL and ELT, the most common I've seen is custom API. So those data sources that I mentioned, like TikTok or Meta, uh, they they give you access to the data mostly from through an API, so custom API. But those common data sources can also be ingested using a tool, a very common tool like uh, where do I write that? Let's add another text box here for the tool. Uh, Things like DLT or data load tool, um, Meltano, which is an open source tool, and there are also paid tools for ingestion. For ingestion, I'm running out of space here. Okay, so that handles the. Just give me a second here. So that handles the part of ingesting the data into the data warehouse. So what other tools exist for warehousing? Um, most of the solutions that I see here are the cloud solutions. So you are very familiar with this for sure. Snowflake, Databricks, and BigQuery. So these are very common data warehouses. Okay, and there's a lot more. So for orchestration, um, tools for orchestration could be Airflow, Argo, Jenkins. So yeah, just to name a few. So orchestration, that's the tool that you use to schedule some some jobs, quote unquote jobs. So if you have like a sync job to sync between the product database and the data warehouse, this is where it happens. So you can create a job in Airflow, for instance, that runs, let's say, every 6 hours. Uh, when that job is triggered, the data warehouse will sync with product DB. So as you can see, it's more of like automation, right? So that's orchestration. Um, okay, so now let's move on to the analytics engineers. So the tools are quite straightforward and simple. DBT, SQL Mesh. Um, that's about it. So DBT and SQL Mesh are the same transformation layer tool. Um, so you know they compete with each other business wise. So chances are you would only in a an analytics team, you would only use one of these, either DBT or uh, SQL Mesh. All right. Now for analysis, where did I put this one? Now for analysis, if you want to analyze using SQL, usually you only use the warehouse uh, solution because the data you can access the data warehouse using SQL. So if it's a cloud solution like Snowflake, there are cloud user interfaces or cloud or sorry web app that you can use where you can run SQL directly on the data warehouse. So um, those transform data, by the way, are also stored back to the data warehouse. It's just stored in a different schema. That's a different schema or a totally different uh, database within the data warehouse. So what I'm trying to say is that both the raw data and the transformed data will be in the data warehouse. So if the data analyst or scientist wants to analyze those data, they can do directly in the data warehouse. So how about Python? Um, so if they use Python, so you probably want to use a Jupyter notebook as well as a tool. Um, what else? And then for all layers, really, I want to write like a code editor, but that's really um, a generic tool. Obviously, all roles here will code, so they need some code editor tool. Okay, and then for here, should I write things like pandas? I guess so, right? So that's a Python package, not really like a tool, but more like a again a Python package that you can use for analysis as well. That is if you use Python for analysis. For prediction, it's also Jupyter Notebook. Um, and sklearn. So this is another Python package. So really depends on the project and the tech stack that your team uses. So it can be PyTorch. What else I have used? Keras, TensorFlow, right? But chances are this is what you're going to use if you're a data scientist. This is the most common uh, framework for making or training machine learning models. Okay, and then for reporting, you have the various BI tools. So this is where things like Power BI come in, Tableau, Looker, Metabase, right? So these are all the tools. And because you will have business users, you will also probably need to have a spreadsheet tool as well, like Excel or Google Sheet, right? So your business users or business heavy users can also interact with your reports because really, you know, the world is so diverse. You can argue that why do they need a spreadsheet when all the data that they need is actually already in the dashboard? But again, the world is so diverse. There are people who really prefer analyzing data in a spreadsheet, and there's many of them. So that's why you have to keep your mind open that there are just people who just wants to export things to a spreadsheet and not use your report or dashboard for whatever reason. But that's very common. So yeah, you need to have this one in your bag if you want to be a data analyst. So that should be all for this session. We covered a lot of things in this session. So I hope this is all clear. You can just leave your questions in the comment sections. In the comment section if you have anything. All right, so that should be it. See you in the next session.